Hello everyone and welcome back. In this video, I'm going to be going over Voltaic cells. My name is Mr. Cobalt and let's get into this. So let's talk about electrical currents. So electrical current is the flow of electric charge. That can either be the flow of, say, electrons through a wire or between substances, or it could be a flow of ions through a solution. Both of those would count as electrical current. So in a previous video, we were talking about redox reactions. We talked about redox, reduction, oxidation. We got to remember that reduction is the gain of electrons by a substance, and oxidation is the loss of electrons by a substance. So remember that mnemonic device: oil rig, oil, OIL. Oxidation is loss, and reduction is gain. RIG, reduction is gain. There's also another one out there, Leo-Ger, Leo, Leo, loss of electrons is oxidation, and Ger, is gain of electrons is reduction. So Leo-Ger is another one that you can use. Okay, so when we're talking about redox reactions, let's recap what we learned before. So here you have a example of redox reaction. So you have solid zinc with no charge, and that's going to react with copper 2 plus. That has a 2 plus charge on it. Aqueous, so this is dissolved in water. So we have a solid reacting with an aqueous solution of copper 2 ions. And then that's going to give us zinc 2 plus. So what's happening is here the zinc is going to transfer 2 electrons to the copper, and that's going to allow the copper, this is going to reduce the charge. So the charge on the copper is going to go from a 2 plus to a 0 charge. So the copper becomes a solid. And by doing so, the transfer of electrons, the zinc transfers 2 electrons. So it's going to lose those 2 electrons and then become a positive 2 charge. And so here the charge goes from 0 to 2 plus. And so here the zinc is losing the electrons. So the zinc is getting oxidized. So it's increasing its oxidation state. And here the copper is gaining the electrons, so it is reduced. And so its oxidation state is being lowered. So in this case, what we could do is we could take solid zinc and place it directly into a solution with copper 2 ions, maybe copper 2 sulfate or copper 2 nitrate. We take a little piece of zinc metal, plop it into the beaker with some copper 2 ions, and the transfer electrons will happen directly from the zinc metal to the copper 2 ions. And so the copper 2 ions is what causes the solution to have a bluish color. And so what will happen as the electrons are being transferred from the zinc to the copper 2 ions, we're going to cause the copper 2 ions to become copper. So the copper metal is going to plate directly onto the zinc. And so that's going to reduce the amount of copper 2 ions you have in solution. And so the blue color will fade away over time. And so therefore, the zinc will take the place of the copper. So the zinc will become dissolved in the solution. And so, again, that can happen directly, or what we could do. One thing I want to mention is that this is a spontaneous reaction. This happens spontaneously. And so what we want to point out here is that the zinc wants to lose its electrons. It wants to undergo oxidation a lot more strongly than copper does. So this is going to more readily lose its electrons. So it's a stronger it undergoes strong oxidation here compared to the copper. And so when you put these together, zinc is automatically going to transfer electrons to copper. And so we have a spontaneous reaction here. And again, when we talk about spontaneous reactions, if we go back to what we talked about before with the change in free energy, remember what free energy is. Free energy is the energy that's available to do some sort of work. So if this is a spontaneous reaction, what's happening is you're going from reactants having a high amount of free energy to products that have a lower amount of free energy. So that free energy change is going to be negative. And so what that means is that some of that free energy was used to do work or can be used to do work. And so what we could do is, instead of putting zinc directly into a beaker with some copper 2 sulfate or copper 2 nitrate, some copper 2 solution, we could separate out the oxidation and reduction half reactions and make the electrons maybe go through a wire instead of directly being transferred from one substance to the other. If we can make the electrons go through a wire, and then that wire can be hooked up to something like a light bulb or a motor, we can cause a current to form, and that current will then allow for either the light bulb to light or the motor to run. And so this is what we call a voltaic cell or galvanic cell. So let's get into this a little bit more. So what I was talking about here, the generation of electricity through redox reactions is carried out in a device known as an electrochemical cell. Now, there's two kinds of electrochemical cells. There's the galvanic or voltaic cell. This one is a electrochemical cell that uses the spontaneous reaction or the spontaneous chemical reaction to produce an electrical current. So you're not putting any energy in. The other one is called an electrochemical, an electrolytic cell. An electrolytic cell is where you are using the energy of the cell itself to make a non-spontaneous reaction go. And we'll talk about the electrolytic cells in a later video. So here we're going to focus more on voltaic and or galvanic cells. Okay, so let's get into galvanic cells. So here, a voltaic or galvanic cell is an electrochemical cell that produces electrical current from a spontaneous chemical reaction. So we're using a spontaneous chemical reaction to produce a current, and that current is going to go through a wire. So here I have a setup. This is what your typical voltaic cell is going to look like. And so let me kind of point this out to you. So here we have two half cells. Here we have the copper, and here we have zinc. And so what's going on here? So here in this solution, I have a zinc electrode. And in the solution here, I have something, it could be zinc nitrate. So here I have some zinc 2 plus ions floating around in here with some nitrate ions. So that's important for what I'm going to talk about in a moment. Over on this side, I have a copper electrode. And again, in this solution, I have copper 2 nitrate solution. So here I have a bunch of copper 2 plus ions floating around with nitrate ions. And again, on this side, I have a bunch of zinc 2 plus ions floating around with nitrate. And so here I have the electrode. And so just like here, because zinc is more strongly going to give away electrons compared to copper, what's going to happen is that the zinc is going to pass the electrons. So this electrode is going to become a negative. So because zinc has a higher propensity for giving away its electrons compared to copper, that's what makes this the negative electrode. And the way you can remember the flow of electrons is the electrons are always going to be moving away from the negative electrode. So why? Because negative electrons are negative, opposites repel, or I'm sorry, the opposites attract, but same charges repel. So if this is the negative electrode, the electrons are going to be moving away from the negative, right? So that might be a little an easy way to remember the flow of the current. So this is the zinc, because it's more strongly going to oxidize. It's going to give away its electrons more strongly. So this is the negative electrode. The electrons are going to travel from the negative electrode to the positive electrode. Let me label these as negative and positive. So here we have the negative electrode, and here we have the positive electrode. So that's the flow of electrons. So instead of having the electrons be transferred directly from the zinc to the copper, we're going to force the electrons to go through a wire. And in going through a wire, they're attached to this light bulb, and the light bulb lights up. So it's doing electrical work. So that free energy we're talking about for a spontaneous reaction is now being used to do some electrical work. And it's going to flow through and go to this copper electrode. Now, what's happening here? Now, where are these electrons coming from? The electrons are coming from the zinc electrode. So the zinc atoms in the electrode are giving away their electrons. And so here we have a zinc solid becoming zinc 2 plus. So as the reaction occurs, as the electrons leave and flow through the wire, we're changing the atoms of zinc into zinc 2 plus. And so as the electrons are flowing through, turning on the light bulb, then they go over here. So then what's happening here is we have some copper 2 plus ions floating in solution. Those 2 plus ions are going to pick up 2 electrons, and they're going to become copper solid. So they're going to plate onto this copper electrode. And so what's going to happen is, as more and more copper 2 ions are becoming copper solid, we're losing positive charge over here. So this is becoming less positive. But over here, notice that the zinc is giving rise to more zinc 2 plus ions. So the zinc 2 plus ions is growing here. So this is becoming more and more positive. If we just left it that way, then eventually this side would become more and more positive than this side. This side would be less and less positive. And remember, the electrons like to flow from negative to positive. So as this increases in positivity and this increases or decreases in positivity, the current is going to slow down and eventually stop. So in order to keep the battery going longer, again, a Voltaic cell is the same as a battery. Cells and batteries, that's interchangeable. So to keep this going a little bit longer, what you can do is create put in what is called a salt bridge. And in the salt bridge, you have some positive and negative ions. I don't know why I have potassium as a negative ion. That's supposed to be positive. So here, because this is becoming more and more positive, then the negative nitrate ions are going to be attracted to this side. So they're going to flow over here, and that way canceling out some of the charge. So keeping the positive charge down here. And then for here, since you're losing positive charge and becoming less positive, more negative, then the positive potassium ion is going to be attracted to this side. And so the positive ions are going to go over here to kind of make this more positive. And again, that's going to increase the life of the cell and keep the reaction going longer. And so, what I want to point out here is on this side of the reaction, on this side, we have the half reaction separated from this half reaction. So we have oxidation occurring here, where zinc solid gives away 2 electrons to become zinc 2 plus. So there's the 2 electrons. So oxidation is happening here in this beaker, right? This is our cell, our half cell here. And then the electrons flow, and then we have reduction half reaction happening here. So here we have copper 2 plus picking up the 2 electrons and becoming copper solid, and we have the reduction reaction happening there. And so that is how a Voltaic cell works. That's how the the electrons are able to flow through and do some work on the light bulb. Or it could be a motor. You can hook up a motor there and get the motor to run. I hope this was helpful. If this was helpful and you enjoyed the video, then please, by all means, like, share, hit that like button right there. Share my videos with your friends. Also, make sure you subscribe to my channel. Hit that notification bell up there. When you click on the notification bell, hit all so that way you can get all the notifications for all my videos. Also, make sure you put a comment down in the comment section. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me and have a great day.